Yeah. So there's, this is used a lot for engineering surveys, okay, for near surface, upper 100 meters, for groundwater exploration. DC resistivity and a variant of it called induced polarization is used quite a lot in the mineral industry. They're for looking for disseminated sulfides and other types of base metal deposits. Um, DC resistivity is not used much in the oil industry. Um, there's electromagnetic variants of that called magnetotellurics and control source electromagnetics, which are related to this but give much deeper penetration than putting these electrodes with much less hassle than spreading wires out on the surface. Um, let's see, is there anything else? Engineering, hazardous waste site assessment, DC resistivity is used a lot for that, or old, mapping old dumps and landfills. I'm gonna go through, right now we've ended kind of like the standard lecture part of it, explaining theory, so now I'm just gonna provide some examples of what it can be used for. Right, any other questions before we move on to the examples? All right, so let's talk about the examples. Here's an example where this is a case where there was fractured bedrock, and the owner of this property was trying to site a well, and so in this case, you always have to look at the color bar, because different people use different color bars, and different industries use different color bars depending on what they're trying to highlight, because red is always usually used to call something out. So the oil industry, red is resistive, correlated to oil. Academics, where people might be looking for melts or magma using these techniques, red is used for conductors. So if I tell you the wrong color is corresponding to something, please call me on it here, because I think these switch back and forth. In this case, red is resistive, okay? So we've got fractured bedrock, so we would assume that the competent bedrock that doesn't have a lot of fractures would be higher resistivity than bedrock that has fractures. Why? Yeah, so we've got, the fractures are generating porosity, okay? And so they're gonna be filled with water, which is gonna lower the resistivity. Does that make sense, everybody? So in this case, you see that in general, across much of the area, there's fairly high resistivities. This is a 2D inversion result. We're not looking at the raw data. The one anomalous case is right in this location right here, where we see this structure dipping down from the top to the bottom. And apparently the owner of this property drilled a well right here, intercepted a water-bearing zone at this depth that yielded higher water production than another location. Okay? So resistivity, because it's sensitive to the fluid content, very good for looking for zones of higher water content. What? Yes, it's electrically conductive, so that means it has more fluid. So it's because this is resistivity, not conductivity. So high resistivity is red, low resistivity is blue. Okay. Caves. Um, there's places in the world where you've got constant near surface conditions and people don't know about it. They want to build something on top of that property, but there might be sinkholes present. We've all heard of examples where something is built in a property, and then years later suddenly a sinkhole forms, causing major structural damage. So one of the things you can use resistivity for is to look for areas where you have karstic terrain. You can look for higher resistivity because the rock, the limestone, even though it's low porosity, it does generally at the near surface contain some porosity. And so it'll be that porosity if it's below the water table, or it'll be partially saturated at least. So you'll have a lower resistivity than an air-filled cave void would be. So this is just an example where they did a resistivity survey across an area, and they noticed in this location right here a very, very high resistivity anomaly. There was a sinkhole here which turned out to have basically come back as a conductive anomaly. They figured that was just basically there was that sinkhole over years had collected clays and whatnot, and organic material in it, and therefore was moist and more conductive. And they noticed another conductive anomaly over here. And they're just hypothesizing that maybe some sort of clay-filled void. Okay? But you see how strong this anomaly is right here and how large it is, and they were able to directly correlate it with they went down to an entrance into a cave, and they were able to directly correlate this cave to that high resistivity. Here's a case of using resistivity to characterize a landfill that had been closed. Okay, we all know that old landfills weren't really built as well as the originators thought they were to contain leachates. Does everybody know what leachate is? No? When basically you have a landfill, basically the trash in a landfill will compress over time and moisture will get in there. And the compression coupled with the moisture will produce kind of a semi-toxic chemical fluid called leachate. Okay? It's all organics and decomposing organic material. Plus you might have things thrown in there like industrial products that people have disposed of. And it tends to be electrically conductive. Okay, so one of the things people like to do when they're trying, once again, to build or reclaim old landfills, is they want to know, is the landfill leaking, and where is the trash, because they're covered with a clay cap, where's the lower density zones of trash versus areas that I could hopefully build on more safely. And so this is just an example where they use the resistivity just to basically map the bounds of the landfill. This landfill was built into a shale, which was higher resistivity. But you can see how the resistivity goes from 200 ohm meters in the base of the landfill, below the landfill, down to very low values of, below 30 ohm meters. Okay? Just to the fact you've got conductive materials. Some areas of the landfill might concentrate metals, and so you would see a very, very low resistivity anomaly in that location. And if this was leaking, because usually they will line a landfill with a clay liner to try to keep fluids from migrating through. But if it is leaking, what you might see is downstream or down hydraulic gradient from it, you might see a conductor existing in the basement, just with higher porosity. And so that would give you an indication there is some sort of conductive fluid leaking from the landfill that might need to be cleaned up. Yeah.
I don't know if you mentioned it, but your power supply, is it standard or do you?
It depends on the size, how big, how deep you want to explore.
And that's one of the factors, that you start off with some acquisition design parameters. That's
Yeah.
the
Yeah. Usually the things for these kind of surveys where you're, going to maybe 150 to 100 feet, they're just totally handheld, battery powered. For mineral exploration, generally people use generators to power the system. case of kind of a geotechnical slash, sand mining operation where the owner of this property wanted to locate, areas of high sand and gravel in an otherwise shaly clay environment. And so you see in this case, the shales and clays, they're going to be lower resistivity because of this, this effect that we have, this charge buildup on plate weakness that we have. And so you see that the sand and gravel deposits, this is two different profiles that were parallel to each other. The sand and gravel bars show for this very high resistivity